Hello, and welcome to another lecture from CyberMD. Today we will be discussing the pacemaker action potential as it applies to the USMLE Step 1 exam. The pacemaker action potential can be divided into several phases. Those are phases 0, 3, and 4. There is no phase 1 or phase 2. The reason that there is no phase 1 or phase 2 is that the fast voltage-gated sodium ion channels that were previously active in our discussion of the myocardial action potential are permanently inactivated. This is because the pacemaker cells have a less negative resting membrane potential than myocardial cells. Physiologically, this is important as it allows for a delay in the contraction signal transmission from the atria to the ventricles, allowing the ventricles to fill before they try to pump the blood. Let's dive in. Phase 4 is where we will start, and in some aspects this can be thought of as the cell's resting state. However, in this phase there is constant action of ion channels known as funny channels. These channels allow for a slow mix of sodium ions inward and potassium ions outward. Additionally, T-type calcium channels, in which the T stands for transient, are also activating and inactivating, allowing small influxes of calcium ions. As a small aside, these calcium channels activate at more negative membrane potentials, opening to low voltage depolarization, and they have rapid inactivation. Combined, the funny channel activity and T-type calcium channel activity creates the slow depolarization that characterizes phase 4. This phase and the channels involved create the autorhythmicity of the heart, and the slope that the phase 4 creates sets the heart rate. An increase in the slope translates to an increase in heart rate as you reach the threshold for depolarization faster. With regards to pharmacologic and physiologic effects on this phase, it is important to note that acetylcholine and adenosine will decrease heart rate by decreasing the rate of depolarization, while catecholamines increase heart rate by increasing the rate of depolarization through increased funny channel opening. Phase 0 is the next phase, which begins at a membrane potential of approximately negative 40 millivolts. It is known as the depolarization phase of the pacemaker action potential. It is the initial rapid depolarization of the cell membrane and is characterized by the opening of long-lasting, high-voltage-gated calcium channels. When these channels open, there is an influx of calcium into the cell. Phase 3, which is also known as repolarization, is the rapid return of the cell membrane potential to its so-called resting state so that the cycle can restart. This is caused by the opening of channels that allow positively charged potassium ions to flow out of the cell and create a more negative membrane potential. In conclusion, the pacemaker action potential is a complex process that is crucial for the proper functioning of the heart. The movement of ions across the cell membrane during each phase of the action potential is essential for the depolarization, repolarization, and contraction of the heart. Understanding the details of the pacemaker action potential is important for understanding the underlying mechanisms of cardiac physiology, pathophys, and pharmacology. Thanks for listening, and be sure to subscribe to our content so that we can continue to provide free medical education and resources to medical students around the world.